Ladies and gentlemen, good afternoon. Welcome back to BASF at K 2025. Welcome back aboard our plastics journey. And this time we're going to take you down Electric Avenue, but in a safe and functionally integrated way. I'm not going to do this by myself, but with my experts here on stage. Very happy to welcome Ludwig Nertinger and Mustafa Hussein from Eaton Industries and my colleague Andreas Stockheim from our PPA team. Ludwig, let's start with you. And give people not a break, but a Breaktor. Yeah? That's the name of this beautiful piece of engineering. Why is it special?
It's special because it combines basically the circuit breaker function and the contactor function in one device. Its party trick is being able to break really high short circuit currents of up to 25,000 amps, disconnecting it in 4 milliseconds and being able to switch back on. So it's great innovation we did.
Wow, that was a lot of technical details already to start us off. Where is it used, actually?
It's used in batteries for electric vehicles, commercial vehicles, whatever kind of sort. And yeah, we see it finding its place in the market very well.
Mustafa, the technical capabilities that Ludwig just mentioned, why are they so important in that area of application for electric cars, essentially?
Absolutely. So electric vehicles are the future of sustainable mobility. Let's start there. So with any new system, they must make sure that they operate reliably and safely. Right? And this goes for all of the driving conditions, all of the load conditions that you have on these electric vehicles, whether it's short circuiting, whether it's overloading, fast charging events, even a vehicle collision, and of course all of the classic driving scenarios, right? So this is where it all starts. And combine that with essentially what we have today in front of us is Eaton's newest circuit protection technology, the Breaktor, right? Is an all-encompassing solution. That's because it can, apart from being the safety device that it is, it can also do switching. Means that it can be the contactor and also essentially the fuse. So with those two separate things now combined into one, it becomes our ultimate solution for the market.
And hence the name that you coined, the Breaktor.
That's it.
Right. Andreas, how did BASF, I mean, BASF and Eaton have been partners for a couple of decades, I would say. How did we get involved in this specific product, and with what?
Yeah, as you just said, so we have a long-standing and trusted partnership with Eaton, and I think this is one of the key success here, that we were successful with our product and to support Eaton, because when BASF got involved very early in the development stage, so we really could support Eaton with simulation tools as well as to find the right product. Yeah, because I mean BASF is offering a very huge polyamide portfolio. Beside PS6 and PS66, we have PPA, so that we really can support them to choose the right and most suitable product, yeah, to bring this innovation into the market.
And which one is it, finally?
It's an advanced T2340 G6.
I wrote it down, it's correct.
Yes.
0G6, it's here. Good.
So the product is used in the inner chambers, so here the requirements are particularly high in terms of temperature, dimension stability, water uptake and so on. So therefore we have chosen the T2340 G6, yeah, because it offers a very high mechanical stability at high temperatures, low moisture uptake, and yeah, that's the reason why we have chosen this product especially.
Ludwig and Mustafa also, how important, Andreas mentioned this kind of being involved early in the development process. How important is that? I mean, how many attempts can you have to develop something like this?
Yeah, so it's a complete new technology, never been done before. So for us it was really important, having a strong partner here that has a good portfolio where we can play around and find the best mix for our application, and I think it worked really well. So we did use a lot of simulation, CAE tools and capabilities from BASF, which made it easier for us to focus on, let's say, other areas of the Breaktor where it needed more attention. So.
From that, Mustafa, maybe you can disclose that. From that point on where you realized, okay, we're going to need something special for that. to this piece? How long does something like this take?
It can take many years. It
Okay.
can take many years. So I look after the procurement group for the enterprise for this particular type of stuff that we buy, chemicals. For aerospace, it could take many, many years. For automotive, it could be within 3 to 4 years. And aerospace, it expands out. So depending on our customer requirements, making sure that we have the right supplier at the right time allows us to be able to have a fruitful journey right from the beginning to the end.
In other plastics dialogues that we had here on stage, we also talked a lot about the kind of regulatory framework. Is this also something that affects your business and maybe also the material choice?
Yes, there are a lot of regulations we have to follow. And it was also one of the key drivers for selecting the proper material. And there are environmental sustainability clauses that we have to follow. Yep, definitely.
How does BASF make sure that we can match these criteria?
I mean, as I mentioned, so we have PA6, we have PA66, but even our PPA portfolio has increased dramatically over the last couple of years. So that we can support the customers with, I would say, 50 to 60 different kind of PPAs. So we have at least 4 different kind of PPA polymers plus PPA blends that we can really choose the right product out of a really huge portfolio. Yeah, and so especially when it comes to high temperature, low water uptake, yeah, specifically need for electrical applications. So there we can offer, in most of the cases, the right product, the right PPA product. If this is not the case, of course, we also can support our customer with tailor-made products.
The topic of CAE simulation also during the development process was mentioned a couple of times. How much kind of time gain does that bring you? Can you somehow quantify that? Or is it just saving money in the end because you're not building prototypes?
It's saving a lot of time and money, actually, both, right? It's hard to quantify, but anything you can do in the software is obviously costing us less cost in physical testing, which is always very expensive. So it's definitely, accelerating us and being quicker to the market, which is in e-mobility, time is money. The market is developing so quickly, and we just have to keep pace with such an, hectic development circles that we have to follow. So it was really, and we use it also internally for our development extensively, just to understand quickly, is it working, is it not working? That's really, really good. Yeah.
Mustafa, to what extent is this, can I imagine this is global? Is this coming into cars all that are being produced all around the world, or is this specific to a certain geography?
It's available for everyone to use around the world, even though it's designed and made in Europe, right? But it's a product for the world. It's one of its kind in the way it does what it does. And there's more out there, really, in terms of exploring different regions and different product groups, and even different industries, right? Going into exploring energy storage areas, going into looking at industrial mobility. These are all more an exploration kind of areas where we can go into with this type of product. So
could it stay the same then, basically, or would you have to adapt it significantly in order to be used in those other industries that you mentioned?
It's pretty much customer and regulation driven.
Okay.
So we would go about understanding, clearly there are efficiencies with staying the same, like with anything, right? But going out there and looking at what your customer wants, a little bit like what you guys did when you guys came to us, right, is clearly the best way to add value, ultimately, to the customer system.
Andreas, you mentioned that the PPA portfolio has also been expanded in the past couple of years. I actually still remember the launch back a couple of years back. What are the most interesting additions to that portfolio, and why were they added to that portfolio? What was the demand?
It's always depending on the customer demand, I would say. Yeah, I mean the portfolio of PPA is so huge because there are so many different customer demands. Yeah, so we started with the PA90, as you can remember. And now we have all in between the 66 and the PA90, all other different PPAs, and that all comes from the different requirements by the customer, which really sometimes there's only slightly different need for the product, which then specifically needs to develop for. That is why the portfolio becomes very huge, but very powerful. Because then we really can choose the right product regarding the technical requirements, but also in regards to the economical values. Because of course you can always use the best product, but there's also a question of price then.
But this huge portfolio doesn't make your life easier if you have to procure all these materials, right?
We just need the right one.
Just one at the right price. I can imagine.
You got it.
Yeah. Let's take a look at next steps. You all already mentioned that this product hopefully has a bright future, also in other industries, not only in electric cars. But what is Eaton looking at when it comes to looking at the future?
There are several arising markets, like the aerospace is transforming into, going from fuel to electric. Battery energy storage is a huge market for Eaton rising. And we just see the Breaktor as a, let's say, a general technology we developed, and now we are trying and understand, let's say, how can we move it from this market into this, and it will be some, slight changes required. However, we think that we just got started basically with Breaktor, and we can expand it to other areas as well.
Mustafa, from your perspective, from your job's perspective, looking at the future, what are capabilities that a supplier must bring to the table in order to accompany you on that journey that Ludwig just talked about?
Sure. Let me take a different angle at this. So, it's not just about material performance, right? We have a huge range of things that we need from a supplier. So, we go into the sustainability world, for example, right? So we're looking at understanding how we can use the same materials, right, with the same performance, but with a reduced carbon footprint, for example. And at BASF, we're able to take advantage of the different types of sustainable options that are available, such as biomass balance and also the reduced product carbon footprint options as well. So if a supplier has the product, right, also the ability to be able to go up the value chain and offer more value in terms of different types of energy, that's a huge winner for us.
Okay. Do you bring that to the table, Andreas?
What do you mean?
Yes, exactly what Mustafa just mentioned, the capabilities that a supplier must have. You can only answer with yes anyway, so no.
He wants to say yes.
Yes,
I'm sure.
yes.
It looks like a yes. Yes, absolutely. And we've utilized it in different divisions. Maybe I'll just talk about that a little bit. So we've actually utilized a special green, essentially, energy that's being produced upstream within the BASF value chain to produce our vehicle materials that we need in our electrical division. So where we've utilized the ability to be able to reduce carbon footprint for the same product, but with a drop-in solution for an existing material.
Okay. In that cooperation and with basically this result that you're obviously very proud of, what electrified you most in the cooperation with BASF?
I would say that finding the right how we can play together, seeing how you can go from a theory into an actual product. That's always very encouraging. I mean, everybody can make PowerPoints, right? But making components and products is just it's really cool.
Something different. Mustafa, what electrified you?
Well, I think the fact that BASF lives up to its name time and time after again, especially where we need you guys most when it comes to developing such new products, right? You was there when we needed you. And also the final product that we've developed is setting standards, right, for safety across the world for electrical vehicles. And that's a brilliant stamp to the collaboration that we have together.
Very positive feedback for BASF's contribution here. So,
it was all in all, it was a cooperation. The cooperation between BASF, Eaton, and the different parties: engineering, procurement, technical service, simulation. Yeah. So when really everybody works close together, then you might well have success. Yeah. So I think that was a key of success also for that application here. Yeah.
Okay. Last question. I mean, you've been spending quite some time here at our booth already, so I just assume you might be willing to come back in 2028. What are we going to talk about in 2028? Breaktor 2.0?
We are working on a few concepts already, and yeah, we will talk about hopefully the next generation of Breaktor and how we can, what has changed, what's its new capabilities, and how we both managed to create a sensational product.
Okay. Can I also expect you back in 28?
Yes, not just for the tea and coffee, but no, absolutely. As you know, my colleague quite frankly said, that this product is able to move on into other divisions within Eaton, into other groups. The electrification of not only vehicles, but all sorts of modes of transport will eventually need a safety device like this.
Thank you. Andreas, you can also come back in 28.
Yeah, I hope so that we are back in 28 with the successor of the Breaktor then, together with Eaton again, yeah. Maybe with more sustainable products, yeah, as you mentioned today. So I'm really looking forward, yeah, to work on the next upcoming project with Eaton.
I'm also looking forward seeing you again, not in 2028, but maybe later this afternoon. The gentleman will stay with us for quite some time. You can actually test and touch and feel the Breaktor. This is a real breakthrough. Thanks so much for your insights and thanks for your attention.
BASF. We create chemistry.